Hello guys and welcome back to the channel. Today I want to show you another 3 group nodes that I created, and one of them you've already seen, it's tubes, but the other 2, it's something new that I've created. And as usual, in the description there's going to be a link where you can download these nodes, but let's first talk about what they are and what you can do with them. And so these are all some kind of a extrude profile curves along a curve or along a path. So as you surely know, we already have that, and it's very simple. It's curve to mesh, but it works really well with Bezier curves. For example, this, it works very well. Let me just show you this. So I'm extruding this object, this curve, it's my road curve profile, and I'm extruding it from here to my profile curve socket, and my geometry is actually my Bezier curve, and the output is just that. I don't know why it turns it on the opposite side, and it works really well. The problem arises when you have something like this Z curve. So if I turn off this modifier, the geometry node modifier, this is a curve. It's a simple curve with a polyline curve with 4 vertices, and if I use this setup, as you can see, something really weird happens. It's not what we would expect, and actually that's something that we already solved with these tubes geometry node, but the tubes only had like circular profiles. So this is a bit different. This is a very this is a custom made profile. So here I have this this road curve that I created, but it can be anything. It could be like this star. And still, if we look at it from the top, it's creating a really weird thing. And why is that? Well, because Blender here doesn't scale these profiles. So if we look at it from this side, for example, and let me just turn on the see-through option, you can see this star is exactly the same in all the axes. So if we look at it straight ahead, it's just that identical shape, and it needs to be deformed because it cannot have the same shape here and also here, and that's because here we have like this line and this line, and what Blender does, it just creates a bisector like this, and it just places this profile here, and it attaches it to the rest of the geometry. And of course this can work with Bezier curves, but as you can see, it does not work very well with these straight polyline type of curves. So we kind of solve that. So here we have our extruder along path node. So you need to plug in the path, which is our geometry, and we need to plug in our profile, and we're going to plug in this into our profile curve socket. We're going to plug in this road curve that we used here and plug it on the output, sorry, like this. And as you can see now, if we look at it from the top, it works perfectly the way it was supposed to work. And it would work also for another type of curve. Let's try this star, and also it works fine. Let's put it back like this. So this extruder also works with lots of different type of objects. For example, here we have a plane. So if I turn it off, you can see this is just a simple plane. Turn it back on, and you can see it's working fine. And it also works with open curves as well as closed curves, so cyclic curves, uncyclic, and of course it also works with these weird 3D shape curves, meshes or curves. As you can see, it's working fine. And it should also work with spiral, and it works with spirals. So if I turn this spiral, sorry, these are all the modifiers to make it a spiral. So this is just a simple spiral mesh, but it still works. But in these cases, you would probably want to use this other node that is the upright extruder. So path here, profile here. And as you can see, this one works right. Let me just look it from the top now. As you can see, so now the same shape is always upright. So what's the difference between these two nodes? So this one looks at geometries and looks at normals of the curves and stuff like that. So it will twist the shape, you know, trying to follow some kind of a normal of that curve. And this one instead will always have this profile of ours. So in every single vertex of this curve, it will be parallel to the z-axis. And that's why this works perfect with these kind of cases, like some ramps or stuff like that. But it will not work for example these messed up lines. Like, okay, so this here is just simple curve in this kind of space. But why is it weird? Because we have a very steep angle here, and so if we put our shape here upright, so parallel to the z-axis, it will obviously be highly deformed. But if you get some kind of a result like this with the upright extruder, just know that it's just the way how it's supposed to look. Even though it looks weird, you just don't want to use it for this kind of geometry. And to prove it, it looks okay. We just need to look at it from the top. So from the top, you see that this is just the shape you would expect some extrusion to look from the top, and that's what we are actually doing with the upright extruder. It looks good from the top because it's parallel to the z-axis every single profile geometry here. And just to show you another example, the same example here. So as you can see, we have another messed up geometry here, and it looks fine from the top. But if we go into 3D, then you see that it's all really messed up. But that's just the way the upright extruder should look. So we cannot do anything about that. It's just something that you would probably not want to use it for. So for example, let's put it back to the other extrude along path, and here you can see it looks fine. But anyway, the tubes. So the tubes don't take a profile curve to extrude along. They just extrude circular object. And why this is so why do we need this instead of just using this one and just plug in this a circular curve here? Well, this one is useful because this one works for multiple curves. So if you have a whole bunch of geometry, like here for example, so here we have some multiple curves. If I just turn it off now, you see this is a mesh plane, and this is a mesh line, and it will still work for these type of objects, and it will still work fine with the tubes, so circular profile. But I wasn't able to do that for the others, so here goes. The tubes will also be available for you to download. Another cool thing about this tube is that you can use it for not only curves, but also, for example, this cube of ours, or any type of geometry, because it will do like a wireframe for whatever you plug into it. So this is also useful, and the other two don't work very well with that. Sorry, I forgot maybe the most important thing, and that's all these things that we have here. So what happens here? Let me just plug in this one again, and let me just see that this one doesn't work at all for this cube. So let's just turn it off, and let's also turn this off. So what we got here, these sockets here that you can, these parameters that you can change. So you can add subdivisions. So as you can see, I'm just subdividing everything, and I don't know, sometimes maybe you would want to use more subdivisions so that you can later deform that shape more easily along some kind of another curve or something like that. But anyway, so this is a subdivide, and then we have a rotate profile, which is kind of cool for object like this or this. So these flat objects where you can rotate the profile like this. So we are just rotating the profile. Just let's look at from this side. It's more noticeable like this. And you just rotate it. Okay. And then we have the offset X and offset Y. So offset Y is practically, in this case, only on the Z axis. But here you notice that something else is going on like this, or here especially. And the offset X, it's just, let's look at it from the top, and let's just, for example, enter this edit mode to see what's going on with the X offset. So we're just offsetting it like this. And that's also something you can do, right? Let's put it back to 0, and that's it. So this is practically the showcase of these three groups. And so this one is already on Gumroad, and some of you have already purchased it. So if you have purchased this tubes node, you can go back to the Gumroad page of that product, and you will find another file that will give you a discount code for buying the whole set of all these three. So you can buy all three of them again, but of course with discount code that you will find in this product here. And for all the others that have not purchased this, you can purchase the whole set, or you can purchase whichever one you prefer. And now I'm going to show you, as usual, as fast as I can and as simply I can, the idea behind these nodes, so that you can create your own if you do not want to pay any money to get these nodes. So of course I will not go into detail because it will last me too much time. I will just speak generally, hoping that you are not a complete beginner. Otherwise it would take probably a couple of hours to show you everything that is going on inside of this node. So let's start with this extruder along path. This is my path. So this is just something that changes whatever is plugged in from the group output. It changes it to a mesh. So if it is a curve, then we're gonna convert it to mesh. And then we're gonna use the subdivide mesh here, connected to this subdivide socket path. And we're gonna go on here, where it's gonna be converted back to a curve. So see, now we're watching what happens from this node. So everything here are curves now. But we needed the mesh so that we can take this attribute statistic and catch the index and the maximum index. And the maximum index and add 1. So the maximum index is 3. We need to add 1 because obviously in this case we're looking at this object right here. There is also a 0 index, so we need 1 more to have that 4. index, and we pass that 4 number that's going to be passed along all the way. So here, for example, we also have 4, but I don't know, here we're going to have 8. Get it? Okay, let's go back to this one. Then let's go to see what happens from here, because here we have our profile curve. This comes out here to the transform node, where it gets translated XY, controlled by the X and Y offset from the group input, as well as the rotate profile, so rotation on the Z axis. So as you can see here, if we see what's going on in this node from this on, it's just our profile everywhere, our profile that gets offsetted or rotated. So if we rotate it, it's going to rotate around here, around the Z axis. Okay, and then this one goes on to connect to all this mess up here that we're going to go back to. But anyway, what happens, let's go back to our path. So our path is here, and this path will capture some, it will transfer some attributes on. So every vertex of this path has information, and we need to collect it and pass it on to all the vertices that are gonna like align here. So if we get something circular, all these vertices are gonna have to have the same information that every vertex of this. So every vertex here is gonna have information that this vertex has. And how do we do that? We do that with this transfer attribute. So here there's a lot of information that goes on, starting from index and position fields, and I'm going to tell you what these are in just a second, but I want to tell you first how these get transferred. So this is all information about these vertices, these only 4 vertices of our curve, and they will be transferred this way. This is a transfer attribute node where you plug in the source, that's our curve, and plug in the attribute that you want to transfer. So this is the stuff we're going to come back to. So here we only plug in the index, so we just need the index. So index 1, 2, 3. So all these vertices that are going to come here once we connect this. So all these vertices are going to have this attribute 0 for this point. All these vertices are going to have 1 as this attribute here, and so on. And position also, so every position here is going to have that position vector value imprinted in all these vertices around here. And how do we do that? We do it with this operation. So remember, this is our profile curve. We just need the index and the number of index, so the number of vertices with this, and then we need to divide it by the number of index, floor it so that it goes so if it's 1.7, it's going to be 1. And then we're going to use the modulo operation using the number of vertices of our path. It's a bit complicated, but the long story short, you just plug it into our index socket here, and you just move it on. But what are these informations that we needed here? So let me just show you in a second. Let's go back to see the whole thing, and let's just delete these. Okay, so what are we doing here? So we are looking at index +1 and index -1. This setup right here, it depends on how many indices are there. And you cannot subtract one index from index 0. So that's why we need to add all indices and then subtract 1, because it's gonna roll in a circle. So practically we need the previous index of the 0 index needs to be the last index. And we do that with the modulo operation, of course, but we also need to add something to it, because okay, if we do the modulo of 5, then we're gonna get we're gonna get 1 as a result. But if we subtract 1, then we're gonna go into -1, and we cannot do the modulo operation. Then it's gonna go all wrong. So I don't know if you got this, but anyway, we need to, here I'm adding 1 index, and here I'm subtracting 1 index by actually adding the whole number of indices and then subtracting 1 and using the modulo. Anyway, so what do we get here? So we get index here, index, let's call this index 1, this is index 0, this is index 2. So here we have, for example, this index right here. So this is index 1. So if we add 1, we have 0, and here we have 2, and here we have 0. And then we are using this modulo operation, of course, to get the numbers in line, and we need to capture the vector of position of that index. So we are actually field that index captures the position at index 0, 1, and 2, and we're capturing. So we are kind of arriving at these 3 vectors for this vertex. So for this vertex, this is what happens. So we're capturing this position, and this position. For this vertex, for example, we are capturing this position, and this position. Anyway, so here we have this is a simple group node that gets you to have a vector from 2 vertices. So we have vertex A, B, and this is a vector from A to B. So we are actually calculating, let's go into C. We are actually calculating this vector and this vector. And then here, so this is this vector, and this here is this vector. Then we are calculating the bisector vector with this. So this is the bisector vector. And here, and then we are calculating the unit vector of the bisector vector. So this is the vector that has the length of 1. And here, down low, we have the angle between vectors. So we are calculating this angle. And then we're dividing that angle by 2 so that we can have this angle. So this is for example, let's call it alpha angle. Then we are subtracting 90. And that's because what we need this dimension, right? We need this dimension, and we have this dimension because this is the dimension of our profile. And so we need this vector, this angle. And this angle is exactly 90 minus this angle. And then by cosine and divided 1 by that cosine of this angle, we can have the ratio that we need to multiply this value to get this value. To multiply this value to get this value. And so for every vertex here, we're going to have a different number right here, because it depends on all these vectors around and around. Okay, a bit complicated as usual. And then I'm transferring that attribute to all the vertices that's going to happen here. Okay. I think I lost most of you by now. Sorry. And okay, so what we got next? So here we have our simple way to extrude a curve. So that's the wrong way. But I still need it because I need all the vertices. But I need to correct it. And how I'm going to correct it? Let's go a bit back. So here I had my mesh to curve. And then I went here and instanced on points my profile. So this was my line, and I just instanced my profiles on it. And then I realized them, so they become meshes. and curves, sorry, curves. With this one, they become meshes. And then I set the position of them to be exactly these. Get it? So as you can see now, they're oriented accordingly how they were here, but they're just profiled. We're missing geometry. And why is that? Because first we need to scale this position here the way they should be scaled. And here is where we use these transferred attributes. So we use our ratio to scale it. So this is ratio scale. Watch this white. So this is the scale. We're using the center as our position, right? So our position of every vertex is the scale center here. And then the last thing we're using is the axis, and the axis is that bisector unit vector. Quite complicated, I must admit, but anyway. Okay, and then when we've done this, we just need to again use this and transfer the position attributes of these elements to this geometry, and the result is this. And then we need to merge by distance, because if we have like a cyclic option, let's go back. So if our curve here is cyclic, so if our is cyclic, then we will not do that with the first and the last index. So with these and these. So these are not getting scaled or anything like this. Nothing happens to them. And in fact, here, if you can see, so these, look, so here these objects are getting scaled, but they are not getting transferred on here, because the selection here tells me if this is a switch. So if it's a cyclic curve, then don't select the first and the last index vertex. So these will not be affected. And then of course, if it is cyclic like in this occasion, then we need to merge by distance to connect it all, and this is it. It's been a bit long, and of course the upright extruder is similar, works practically the same way. There are some differences, but I'm not going to go into that because more or less I showed you the principle of it. And the tubes, of course, there is a video on tubes since I made it a couple of months ago, so you can watch that. And that is it. So remember, you can download these files. It's a perfect way to support this channel. And as usual, thank you so much for watching, and I will see you in the next one. Bye bye.